Well, good evening, everyone. We've actually come off of an incredibly successful workshop on Earth observations all day long, and I called everybody to order by waving a red flag. Well, actually, it was a rally towel. Unfortunately, that's upstairs, so I forgot it to come bring it back down. But I'm Ann Bartuska, and Senior Advisor here with Resources for the Future. I'm really pleased to have all of you in the audience, as well as our upcoming panel on this RFF live event on taking the pulse of a changing planet. Very excited about the individuals who are going to be on the stage talking to you tonight, and as well as many of you in the room that I know and those who I don't know. I think we have an opportunity to have a very engaging conversation. Most of you probably know RFF, but for those of you who may not, we are an independent nonprofit research institution based here in Washington, D.C., and we focus on improving environmental, energy, and natural resource decisions through impartial economic analysis, research, and policy engagement. So the brand that we really cherish is that we're nonpartisan and we're unbiased, and we really do believe in the quality of the research that we do and the quality of the analysis that we provide for policymakers. So one of the ways we are able to bring our knowledge to and others to the larger public is through these RFF live convenings. And we've really had some wonderful opportunities to bring leading decision makers and policy thinkers to really start talking about a shared understanding of major issues, and maybe to tee up some new ideas that some of you may not have thought of, and that can leave and think about new opportunities for your own work, as well as new partnerships. Just a little commercial interruption. You can find more about the speakers at the seat, but also we have folks joining us online, and you can use hashtag RFF Live on Twitter to join the conversation. So I encourage those of you who are online or even in the room to be using that freely. And now let's go ahead and bring in the contingent. I'm just going to let everybody sit down, and then I'll go down the line. So tonight, our moderator is Andrew Friedman from the Washington Post, who specializes in a lot of the air and space as well as science issues. And then moving to his left, we have Robin Bell, who's with Columbia University, but is also the newly established president of the American Geophysical Union. To her left is Anne Hale Milaresi, who is the CEO of Radiant Earth. And then finally, on the far end is Ellen Stofan, former chief scientist for NASA, but now more recently the director of the Smithsonian Air and Space Museum. So an exceptional group of women, an exceptional panel to talk about our topic today, taking the pulse of a changing planet. And Andrew, over to you.
Thank you. Definitely a little intimidated by this panel. Robin, you have a mountain in Antarctica named after you. I don't have one yet.
Not yet, right? You just have to
Not
wait.
yet. It's more of a little hill. Don't mean to discount any of your accomplishments either.
I don't have a mountain.
Not a mountain yet. My first question, I've spent the last 2 days covering wildfires in California. And one of the things that I noticed that's different this year from previous rounds of wildfires was we were finding out via private sector satellite companies and via NOAA of every single hotspot detection in these fires overnight and during the day within minutes, sometimes less than a minute of when they developed. And firefighters were using that on the ground to protect communities and to protect very expensive things. Today, they likely, hopefully, saved the Ronald Reagan Presidential Library, but it was a close call. So my question is sort of a very broad question, which is, we seem to be on the cusp of drastic expansion in we're already in a drastic expansion of what we can do in space, obviously, and with Earth observations and applying Earth observations to different sectors of the economy and different uses. What are some of the most exciting examples of either research consortiums or applications that you're seeing now, or things that you're looking forward to being able to do now that you couldn't do before? Because I find this area of science and research to be so much more exciting than a lot of the other things that I deal with, even then more so than a weather model of a squall line around Halloween tomorrow night, it's just, there's just an explosion in information and how we can use it and how we can translate it. So I just wanted to get a conversation going among you three, really, about kind of where we are and where we're going, and what decisions maybe need to be made at a government level and at a commercial level to direct this. I'll kind of jump in on occasion, but I just wanted to broadly kind of tee that up and let you guys have at it.
Well, I'll jump in, just because I'm to your left. I like to think of how 100 years ago when AG was founded, we hadn't even figured out that the continents moved. We hadn't come to that agreement. 60 years ago, we didn't know how thick the ice was. We didn't know how much ice was on our planet. We just thought it might be a little bit of scum on top. Turns out it's like 2 miles thick. So to me, and now we know that the ice sheets are speeding up, that they're dropping because they're like mozzarella cheese and you stretch them, and they're losing mass. And those are from 3 different satellites. So to me, we're at this precious moment where we as a species can actually look at how our planet works. And that's kind of what you were talking about, how fast we can see how our planet works. What excites me is how we can integrate all those observations, whether it's the wildfire that's about to pop next to the Ronald Reagan Library, or what part of Antarctica is going to change and where does that matter? So to me, it's how do we move forward as a species, figuring out how to integrate that data and get it to those communities. Sea levels is a little slower than wildfires, but it's the same deal. It requires more than just one data stream. To me, it points to how we have to move to structures that allow us to collaborate. I don't know whether that.
No, I agree, and I think, in this case, I really want to make sure we give a huge shout out, though, to NASA, the Earth Application Group, Lawrence Friedel's work, because the reason we're at that place is because there was a conscious investment in the technologies, the satellite sensors, improving the sensors, attacking wildfires specifically as a problem, and it wasn't just NASA, right? It was multiple federal agencies that really came together to work on wildfires. And unfortunately, because of the situation we're in with climate change and the rapid intensification of these fires, there was a conscious effort knowing that wildfires were going to become an increasing problem, but it was that investment in technology and research, knowing that this problem was coming, that allowed us to be at the point we are today. And I think that's really important. Scientists sometimes do know what they're doing.
So, just sometimes?
All right, I underestimate.
A lot of the time it's just, throwing darts against a dartboard.
Yeah.
So as a remote sensing scientist who's been practicing in the field for right at about 35 years, it's amazing to me what we can do now, which we took years to do 35 years ago. And perhaps one of the best examples is back in the late 80s, I worked for the state of South Carolina for the Department of Natural Resources, and we built the first large, very detailed watershed database of a beautiful river called the Edisto River. And I'll never forget when I bought our first gigabyte on a sun system.
Yeah.
And it was $24,790. And within a month, my system administrator said, "Ann, we need more." I was like, I can't go get more money. That was a lot of money. I was in the airport in some international city not too long ago and lost my thumb drive and bought one with 10 gigabytes on it for $20, and that was overpriced. You look at the intersection of what we can do now with technology and the plethora of data that we're now receiving, both from private sector commercial companies, whether it's electro-optical data or atmospheric data and radar data. In addition to the NASA data sets and the Copernicus program and now the Chinese programs, we are awash in data. So how are we going to analyze all that data? And to what end? For what cause? And then now you look at the onset of machine learning and artificial intelligence, and that's the only way we're going to be able to analyze on a daily basis the data that's been made available to us by both the public and private sector. I have never been so optimistic as I am now about the future of Earth observations and our ability to contribute to a piece of the puzzle of the science, as well as solving some of society's most difficult issues, like the one I'm primarily focused on is food security in the global south, and the advances that are being made there in India and Africa and Southeast Asia.
Alan, you brought up a point in terms of the public investment that we made going back, more than a decade, that brought us to where we are now. Both NOAA, NASA, other agencies, universities. Do you see that, right now we have a lot of going into machine learning, we're trying to figure out how do we process all this data and turn it into actionable information, actionable intelligence. And that's one stream of discussion that I think we should go down and follow. But one question that comes up a lot talking to scientists is, well, nobody's really that confident in us making those kind of public investments right now or again. That the balance of public sector, private sector research and exploration in space is obviously changing. It is on the exploration side, obviously. You have companies from SpaceX to, Virgin Galactic and the company owned by the person who owns my newspaper as well, Blue Origin. But and that wasn't a plug for Blue Origin. I was literally just trying to remember the name. But do you see us making those R&D efforts now that will get us to sort of a similar point in 10 years, 15 years?
Yeah, I think so, because when you look at issues like water, and we're getting better and better at looking at all parts of the water cycle, soil moisture, looking at water reservoirs with drought, the way we've been able to with GRACE and now GRACE follow-on. I think we're going to keep pushing the sensor technology because the questions are going to get harder. The issues around climate mitigation and resilience are going to get harder. The questions are going to keep pushing us towards higher and higher resolution and better data. If you look at trying to track methane emissions, carbon emissions from orbit, we're not quite there yet. So that technology is going to keep getting pushed. And I'm actually pretty optimistic that if there's a big science push, and even more if there's a big far end, like we need to understand methane, and we're going to have to do it with satellite, and it's hard, and we're just going to keep pushing the technology till we get there. I'm actually pretty optimistic the investment will come.
Okay. And I actually, to follow on that, I think it's pretty important that it's public.
Yes.
Because the paper I'm working on right now is one I made while we were looking at my phone one day, and the images on Google Earth. I'm terrified of data becoming so not everybody can get it. That is what the beauty of our knowledge is built on, that open access. The fact that so much of this data is collected by NASA or ESA, and it's available to every smart mind out there. And I worry that if we don't continue to invest, we'll have a harder time having access to it, and we won't be as open or as innovative.
And I think it's actually critical for resilience in the developing world because especially those countries. You know, if we're going to be helping, like NASA's Surveyor, it's a partnership between NASA and USAID, where we work with countries around the world to help them access publicly available data to help with their climate resilience. To me, it's really critical that we continue to have access to that data.
So, I mean, I agree with you, and I have had the opportunity to run as a CEO, two commercial data companies, one Earth Data International and one Planet IQ. And I've also been a federal government employee and a state government employee. And I think that there are unique roles for each data stream. But when it comes to the science, I promise you the commercial sector isn't going to do the science for free. And the data is not going to be distributed openly for open access. And I think all we need to do is look to other governments around the world and the trends of where they're investing. If you look at the Copernicus program of the European Union, I believe, Lawrence, correct me if I'm wrong, that is a $6 billion program, all on Earth observations. And not only does it go into the flight hardware, but a lot of money goes into the applications. And to streamline, mainline those applications so that they are directly informing the governments, so that it becomes a part of the government workflow and it becomes absolutely needed. And I think that's a big issue that the United States, NASA and NOAA need to reflect on, is how do we get to a program like Copernicus? They are closely followed now by the Chinese, who are investing massive amounts of money because they realize, I think, and are being, it's a good industrial base, economic development, education activity, but there is real value in investing those public dollars. But I, at the end of the day, see where there's tremendous value in the commercial data sets as well. And there are business models out there that make those companies going concerns. And again, in the international development community, I see it on a regular basis where the African data cube is being built with Landsat. But Maxar technology, Digital Globe, is doing a tremendous amount of work with the Gates Foundation on an annual basis to look at Zika and polio, and they need that level of resolution to get to the solutions that they're trying to develop.
Mm-hmm. It's kind of a strange question, but sometimes when I talk to normal people.
Oh, good.
Nobody here.
So what do you think about that?
Nobody here. About what our capabilities are right now, and how amazing it is that we can, anticipate an El Nino event certain months in advance, although El Nino predictability hasn't really improved all that much. But that we can observe what's going on. Basically, we have satellites that are showing us HD video in real time of certain points on the Earth all the time. They're, I think, very surprised by that or excited by that and interested in learning more. For the people who are watching via webcast or other people here who may not be working with Landsat data every day, what would you suggest that they do kind of as first steps to dip their toes into this stuff and realize what it can teach them about their world?
Well, I would tell them just to go to Google Earth, go look at their backyard, click on the history piece, and like my little cabin in the Adirondacks, I can figure out when the storm came through that knocked down all the trees that let me build the Canva. I can see when I put out the beehives. You can actually, with this imagery that's just on your computer or on your phone, you can actually get a sense of the environment you're in and what your vulnerabilities are. I mean, it suddenly made me realize I should worry about the trees on that side of the clearing because they went once before. But that's just there. Just one button on the computer, and I can look at the history of the environment around me. And it's just like with climate change. I think if you can connect people with data that means something to them.
Right.
That's what I would tell my neighbors to go look and see when you put in your pool. I don't know, what would you?
You know, I would probably say, because, you know, whenever I go out and talk to the public and I would talk about programs like Surveyor, I would have people say to me, I didn't realize NASA did Earth observations. And you're like, wow, really? Okay.
Part of it's part of our mission. It's part of our mission.
Yeah, but okay, they don't. So we need to keep communicating what we're doing. So I always say, you know, go and look at the range of problems that are being addressed. And obviously it's from the private sector all the way through the public sector, the range of problems that we're now addressing with space information. And of course, one of the things I'm doing is we're creating a new gallery in the Air and Space Museum that's called One World Connected, where we're going to talk about the huge range, you know, from all the ways space-based data is being used in agriculture to how it's being used understanding water resources, to helping, you know, individual communities around the globe, you know, trying to educate the public that space data touches almost every aspect of their lives and they don't realize it.
Mm-hmm.
Yeah, I think Google Maps is a great example. I remember, you know, when I told my parents I was going to get a degree in geography, my father was like, oh, God. And my parents are deceased now, but I think it was 10 years ago when I showed my mother Google Maps. She was like, I get it, you know, I get it. I think it's so pervasive now. And to some extent, I mean, clearly we want them to understand Earth observations, but to some extent, that's a success, right? That these tools are so embedded in citizens' lives that it's just so exceptionally useful, right? And so I think it's certainly not an overnight success. It's been a 40-year success with thousands of dedicated professionals making that happen. But I also think the new generation, the millennials, I personally love working with millennials. I find them highly educated and relatively easy to motivate. It's just so intuitive to them. I don't think it's a big surprise. So I think I run into problems explaining the value of Earth observations to my peers. And we're aging out, so.
In what ways do you think that journalists should be using this information more? Because I'm not asking, like, what should my next story be?
It would be nice if we could tell you, right?
It would be nice.
Okay. We'll start thinking.
But I find that I'm often looking at NASA's Worldview Explorer and going through the different data layers and saying, well, can we craft some sort of narrative around peat fires in Indonesia, for example? Or does that just need to be a graphic story, or can we send a reporter there on the ground? A satellite was never really an assignment editor before in a newsroom, but I think increasingly they are. Do you see that the applications mostly in development work as well as climate change work? Like, I just feel like some news organization, probably the Times, because I feel like they have 1,000 people on their graphics desk, is going to increasingly blend observation. It's going to be, you know, we have data-based reporting. That's a thing. I'm not really sure why we can't go one step further into Earth observation-based reporting. It's all part of the same continuum. Do you see reporters doing that now, or do you see that as a separate category, or am I totally off base here?
Well, I'll tell you my story, and unfortunately it is that newspaper you mentioned.
Mm-hmm.
And this came from me being convinced that virtual reality was a way to get people to see things in Antarctica that they never had, you know. And I just became enamored with the idea of getting a virtual reality team to go to Antarctica. And we did. And they went and they shot.
I saw it. It was great.
Isn't it gorgeous? But to go to the New York Times, it still gives me goosebumps. As a geek, to go to the New York Times, so this is exactly to your point, and to walk in the floor, and there's space probably 3 or 4 times the size of this, and every computer has an image of Antarctica on it. Oh my God. For a geek, that's heaven. And they're actually using NASA data to make these spectacular animations that actually were more intuitive than more beautiful than the ones that NASA had produced, partially because I think they had more graphic artists. The ice was blue when it moved as opposed to pink or green, which there's a little bit of pink ice. It's in northern Greenland, and it's a special algae that grows, but most of Antarctica isn't pink. So it was just, to me, that was, oh my gosh, I think that is where journalism is going to go, because I think we have this capacity both to share the data in a way, because I show the movie of the ice sheet flowing all the time, but this was on the New York Times, and that's way more than people go to NASA's visualization page. So I do think that our understanding how our dynamic planet works is going to move more and more into the newsroom, and increasingly more data sets.
Well, I think it's a way to show data. If you think of, everybody's hearing about these power shutdowns in California, right? But if you put a single image in the paper that shows a big chunk of California at night, normally with electric lights everywhere, and then an image that shows what's happening as PG&E shuts off the power to areas,
Right.
People get it instantly. And I do think most people are visual learners, and so when you can show them something,
Right.
and many of us skim through newspaper articles relatively rapidly, sorry. And
I worked at Axios, I know.
so I think the more data you can show, the more you can use that satellite data to make a point, and the data are there to allow you to do that.
Yeah, it's so consumable and it's so friendly visually, I think. And I think, news organizations, high quality news organizations like yours, are going to have to go there to help persuade humanity that climate change is a problem, and it's a problem in your neighborhood, to get them to consume those stories. And it is a lot of extra effort, but it's not nearly as difficult as it used to be. So.
Yeah, I did an event with Catherine Hayhoe a couple weeks ago, and she was putting up her map of like how many people actually accept that climate change is happening, and the percentages are fairly high. And then how many people, and this was just for the United States, how many think that climate change is actually going to affect them? And that number was really low. And so to me, when we start worrying about how do we move the needle on this issue, you really start thinking, how can we use these data with stories, because it's stories that actually get people motivated. How do we use these data to start moving the public to understand, oh no, this is actually going to happen to you?
Yep. Part of me wonders when a news organization is going to just launch their own satellite, actually. Because we were looking for that data set the other day when they started the power shutdowns. And we were thinking, okay, we're going to get that in another week. In another week, it's just not going to be there. The story. So yes, please. These things come up like all the time, really. I guess I want to shift the focus a little bit to talk about STEM and the way space observations and Earth observations relate to getting people interested in STEM. You guys are all enmeshed in STEM education, and obviously, I feel like, Ellen, the first place that people might get interested in these topics are at your workplace right now. And Robin, you teach at a university where I went for a graduate degree, and I got to go to Lamont one day a week. It's a beautiful campus, and talk to amazing scientists, and realized that I didn't have nearly the math or physics to go for a PhD and that stuff, but could understand it well enough to explain it to people in English.
You don't want to use equations?
Not well. I mean, sometimes yes, but I guess, what do you see as some of the breakthroughs that we've had recently in understanding where to invest and how to motivate people, and what are some of the barriers still remaining towards getting more people interested in STEM education?
Well, I think one of the things we know is, despite a lot of investment, we still haven't really been moving the needle in certain, especially in certain subjects, computer science, engineering. The numbers of white women and people of color really haven't been moving the way we would like.
Right.
And so to me, we know it's a pipeline problem, so there isn't one solution. There has to be lots of solutions. And at the end I deal with, which is the younger end, you know, to me, the most important thing is to start out with, are we telling stories of people that look like all of our population?
Right.
And we don't, right? I mean, everybody knows that. There's lots of studies on this. We need to fix that. The other thing I would like to see, and is something I'm working on at the Air and Space Museum, is how do we start linking all these programs together? Because I have some great programs, I do great work with these kids, and then I say goodbye to them. And so how do we help become their helicopter parent? How do we help move them from program to program to program till I can give them to a university? And then we know there are issues at that level, we know there are issues in the graduate school level, and we know there are issues in the workplace. You know, so we have to solve all of these problems. It's not just a single problem. That's why it's so hard. What, you know, why did it, sorry, this is my new soapbox. Why did it take from 1984 to 2019 to get, you know, where we went from one woman having a spacewalk to two? You know.
Spacesuits.
Yeah,
Spacesuits.
well, it was the spacesuit. Well, the spacesuits, and there's hardly ever two women up there.
Yeah.
Why are there hardly ever two women up there? It goes back to this pipeline
Pipeline
problem.
problem, yeah.
We have to fix this. It's ridiculous. We're leaving talent on the table. Not that
I actually
get
feel like
upset
we're in
about it.
I know. I'll get on my soapbox. Now you're on your soapbox, I'll get on mine. Having just spent the day at an AGU event talking about what do we do about harassment in STEM. And the cultural, we were just talking about it before we came out, the cultural issues in science and technology, and engineering and math are what have kept us from diversifying. You know, we have driven much of the talent away. But the good news is, the things that we used to not talk about, we're now talking about. We have a chance now to make this, you know, studying these amazing images. I was just look at the images that are on the wall. To study our planet, we have a chance to change the culture and attract people, and our science is more relevant than ever before. I think that's something that there may have been some hesitation to go into Earth and space science, because maybe you could go work for, I don't know, an oil company, or it didn't seem like a lot of the work was relevant to what your mother and father cared about. But now we know that almost all the earth science we do is going to inform the future life on this planet. It doesn't matter whether you're covering trees or whether you're covering ice sheets, right? How did I know covering ice sheets was going to matter when I started 30 years ago? We didn't. Dumb luck, right? But, you know, so I think we're in a unique place, is that we've recognized some of the fundamental barriers that are keeping the kids you work from graduating in our program, and that if we are thoughtful, we can attract the talent we need.
Yeah, I think a couple of observations. Again, I'm very hopeful. I remember the first American Society of Photogrammetry and Remote Sensing conference I went to, which was here in DC in 1982. There were about 2,000 people present. There were 3 women. I was 19 years old, right? 1920. You go back to ASPRS now, and it's probably 35%. So that's moving in the right direction. A better example. So I was in Malaysia 14 months ago for a conference on remote sensing in Malaysia. It was a pretty big conference, about 1,200 people. I would say at the general conference, it was about 70% male in Malaysia. I went to some of the more technical sessions on agriculture, and I would say it was about 60% female. Now, those female women, they were all sitting in the back of the room. Of them, all of them appeared to be very conservative Muslims, but they were the ones paying attention, right? And so that was really good news. And I'm starting to see that more and more. I see that in Africa. Certainly there are big cultural issues, but the women are stepping up and getting the work done. So I'm very hopeful. I do agree on the pipeline issue, and I think we have to be very purposeful in working on the pipeline and on the culture. Certainly, I'm sure all three of us have had our share of Me Too moments in the past in this culture, and that is changing now.
We have just a couple minutes to wrap up this portion before we go to questions. The last question that I give on any interview that I do, like over the phone, is there anything else that you want to add before, that I didn't get to ask? And a variation on that is, I guess, is there a challenge or a question that you most look forward to Earth observations answering in the next, say, decade?
I would say there are two for me. One is food security in the global development community. I mean, this is a big problem. There are a lot more people than there used to be. There's a recent estimate that the carrying capacity of the Earth is 3 billion. Well, we've got a problem. And food security in the global south is a big problem and will only get worse. And I think there's tremendous opportunity, and NASA's Harvest program is focused on much of that, and it is a great program. But I think there's tremendous opportunity to support that. And then I think I come back to Ellen's comment about climate change in your community, right? Because you have to bring it home. Intellectually, I think many of us and even the broader society may someday acquiesce that climate change is happening, but you bring it home when your home gets flooded over and over and over again, and you can't get flood insurance. So I think Earth observations and bringing the climate change issue home to the average citizen can have a big impact on society and how we react and change our behaviors.
It's funny because I always go much smaller than I think to convince people that climate change is real. I always talk about their daffodils come up earlier, and they're catching different fish, neither of which I think I can use satellite data to tell them.
You could use drone data.
I could use drone data, but not, and believe me, I do airborne remote sensing, so it'd be fine. We could image, but I'm not sure from space if we can image those daffodils coming up.
Mass migration due to climate change. We know where the water's going to go. We know the levels, we know where the people are, and we know where they will no longer be able to be. And if we start really looking at that data now and really start trying to find solutions now, we have plenty of time for that not to cause, global problems because of mass migration. We saw what a relatively small amount of Syrian migration did to destabilize governments all around the world, I would argue. And so we're talking about migration on a much larger scale than that as sea levels come up. And again, we know where it's going to be, and while we don't have an exact timeline, we have an approximate timeline. And we know we have time to try to find solutions to that, and Earth observation data can really help with that.
I'll actually just riff off of that, whereas I actually don't think we actually know how it's going to go up, because there's so many things we've just learned in the last decade. The fact that, each ice sheet doesn't make the sea level go up evenly everywhere.
Right.
And that we now know, like the reason we always hear Norfolk in the news is not that it's a special play. That we actually have to start looking at the sea level problem as a system around the globe.
Yeah.
But I think to go one step further, my question is, can Earth observation help us at the other end of the problem? Is there any way that we can think about not just building walls or moving people, but is there something we can think about doing to slow down the flow of the ice out of the ice sheets? It's something we don't like to talk about. But, again, that's the thing that we need observations for, to say, okay, can we look at this as a system? Is there some way we could actually maybe engineer the ice sheets? I don't know. It's one of those, that's one of those things that, if I'd really like, I'd like to know the answer to that. Is there some way to change how fast sea level's going to go up?
Right. But for that, would you be talking about, geoengineering and solar radiation management, or would you be talking about something else?
I'm talking about something else. I'm talking about, whether or not, there are a couple of ideas out there, but, quite frankly, the size of the intellectual community working on it's so small. I don't think any of the options, whether you blow snow here. I think they figured out if you blow snow in one place, you make the ice sheet too steep and it flows just as fast. But there are other things you could think about doing, cooling down the edges.
Yep.
Yeah, I mean, it's a problem that I don't think we've got our heads around looking at it that way. Directly looking at the ice sheets as opposed to messing with the solar radiation.
Right.
But I think it's interesting that all of us have talked about things related to basically what affects national security, because we're talking about countries being destabilized around the world, whether it's because of food or lack of food, lack of water, or lack of place to live due to sea level rise. And so to me, Earth observations are just increasingly critical to the security of humans on this planet.
Yep. On that note, because I think it is a very good point, I think we'll end there, the panel portion, and go to audience questions. I think there'll be somebody with the microphone. Yes, I see it being handed off in the back. And if you want to take a question sort of starting from the back and working your way forward, I guess.
Hi, I've been working on trying to fund Earth observation for 3 decades. And obviously in NASA, you're competing with human flight. USGS is competing with national parks. Privatization of Landsat did not work. How do you see funding this public good, and realistically, not just more money for science?
I think there's a great model out there, and I think it's the Copernicus model. The European Union has a different industrial policy from NASA and USGS. Their research missions do pure research, and they look for applications that have proven return on investment. They monitor those, they then fund those, and they fund not only the satellite, but then, and this is where it's very different, generally not the academic community, but the commercial community to take that to scale. And we're not talking just about Airbus. They invest a lot in small commercial companies. And that is just in the last 3 years that I've been working in this community, the growth in Europe around small commercial, many of them with a social mission. Synergize is a great company I would mention in particular. It is really pushing it out. So they see the growth in their industrial base and in jobs and in better solutions for their communities, and it has a self-reinforcing effect. But I think it is going to take a different business model and a long, hard look at the mission of Earth Science Enterprise, and clearly there are some invested organizations and entities that aren't going to want to see that change. The other frustration I find is now, and I know this is a really hard problem for NASA and for NOAA, is so much of the funding goes into the launch and the manufacture. And I think the private sector has proven that there are faster ways to get this done when you're unleashed from what I would argue is the defense industrial base, who has every incentive to keep these satellites as big and as expensive and as heavy as they can be. So, not to get political on you, but I do think, though, the Copernicus program is a great example of how to do public good right.
Anybody else want to make a comment on that question? Or?
You know, I guess I remain optimistic that NASA has had a huge amount of bipartisan support. It continues to. The Earth Science Program has a fair amount of bipartisan support. And I think that the work they do, especially with the academic community, the investment in university-based research that really helps us better understand this planet, I think has been critical. It's gotten us to where we are now. Could it be more? Yes, but I actually think there's been a lot of positive movement over the last decade.
It's actually interesting. It kind of gets back to your workforce question. I actually would argue we do not have enough people working on remote sensing and planetary science.
We have a lot of data.
We have a lot of data, but we don't have enough.
No.
Back to your pipeline problem, we do not have enough intellectual horsepower. So I like to say they're like maybe 1,600, maybe 2,000 people studying ice sheets in the world. You know, there's 130,000 people in law school every year. So, you know, compare.
Most of them are miserable.
Yeah, I know. And you have way more fun, but don't you think there should be more?
There's not a lot of private sector incentive to go do ice sheet research. That has to be a public good. And so I do think, you know, we've got to increasingly just keep pushing that this is really critical research.
Right.
Next question. You in the, I think that's an orange sweater.
Orange for Halloween, sure.
Yes.
Great, thank you. I'm a climate urbanist and a researcher here in the DC area. I'm interested to know, it's great that we have all this data and it's wonderful, but as a practitioner that works on the local level and works with communities both in the US and globally, the ability of these, whether they're urban planners or whether they're civil engineers, to utilize this data is a challenge, and many of them don't even have access to the data, and if they do have access to the data, they just don't have the capacity, nor, as we talked about, the workforce to actually utilize it. So how do we overcome this dilemma?
If I was, in charge of the world, I mean, I'd have every community planning office actually have somebody who knew both about climate processes and also how to manipulate the data sets we're talking about. That's what I think that should be our goal, because that's the information our communities use, and we have to figure out how to educate and get those people with the resources in place, because that's how we're all going to make better decisions. That's what if I was in charge of it.
Right, and I think, we did make a lot of progress in saying, how do you turn NASA science data into actionable information? That's obviously what a lot of what the Earth Applications Group at NASA has been doing and NOAA has worked quite a bit on that. The Ag Department has worked on that. So there's been a number of people over the last decade that have really tried to move, how do you turn that exact problem that you're talking about? Could we go a lot further? Yes, there's not nearly enough investment, because to me, we are not going to become climate resilient until that is the case, and we're certainly not there yet.
Next question. Yeah, go ahead.
Hi. Andrew, I just want to congratulate you on the Capital Weather Gang.
Thanks.
If you live in the Washington, D.C. area, you're lucky. If you're not, but thanks to people like Jason, Sam now, and Angela, I think you've done a great job. Now, my real question is addressing something that Ellen said earlier. I'm a 45-year plus meteorologist, and I've been involved in 4 or 5 different satellite system developments. And I agree with you, NASA is great at technology and being at the table and developing things, but also let's not forget that there are other communities involved, the DoD, NOAA, and they all play in the requirements process, which is really the basic thing there, and users, and that's one thing I want to say is that users need to be more involved. I was a user for a long time as a meteorologist, and I never thought the user community was involved enough in development of these systems.
No, I agree, and I think, historically, it was really fascinating to me when I was at NASA to really be thinking about, we've gone from this era where Earth observations were, first of all, driven by scientists who, I came out of the radar community, and you'd go to meetings and people would spend days talking about, how a different, wavelength band of radar interacted with the surface, because that was what was the problem. And it was always like, someday we'll actually apply this to problems. But for now, let's get back to how does that sensor interact with the surface? And we've come so far. That was, back in the 1980s. We've come so far going from data to actually solving actual problems. And now, to me, we're at a point where we understand the data sets well enough that the users should actually be helping to set the requirements. Well, I don't think we were there before because, frankly, we didn't understand the data sets well enough. Now we do. Now I think we have to move into a more hybrid model.
Next, we'll take one more question down there and then come up here. I saw a hand go up somewhere back there. I'll let you choose.
We need another woman.
Yeah.
I wanted to push some more on this conversation about, I really appreciate the conversation about the value and sort of how we talk about the value of Earth science and observations from space. And it does become somewhat political because I'm interested in your comments on how we talk about and how we think about relative value in things like, so constellation satellites, for example, have a lot of potential to increase the data and the kinds of data that we can get for Earth remote sensing, for terrestrial communications, but then they also have significant implications for our view of the night sky and how the world gets to view the night sky, and for space debris and other finite resources. And there are also competing thoughts around, or competing issues and sort of political issues around the electromagnetic spectrum, which is also a finite resource and has and access to better communication for the world may have implications for our ability to get good Earth science data or other kinds of data. And so I was wondering if you just talk some more about how we think about some of those issues and make sort of the hard choices, or how the value for Earth remote sensing data plays into those conversations.
So in a couple days, I'm actually heading to Dubai to a World Economic Forum meeting where I'm on the Council on the Future of Space Technology. I'm like really long title. And one of the things that we've been working on through that council is how do you get all the companies involved with who want to put small satellites up into Earth orbit. How do you move towards a system where you almost develop a leads-like rating system to try to get them to have better behavior? Do you have a disposal plan for your satellite? Where exactly are you going? Because we've already seen at least twice that I know of, and I'm sure more times, where we've had to have satellites, including Earth observation satellites, move out of the way of other satellites. And yet there's really no regulatory, it's kind of the Wild West up there. And so in that group, we've been saying, can we help on this issue of how do you get companies to sort of come up with better behavior standards? So that's just one small of the many issues you brought up. And I do think, we have to make sure that values move into space with us, and good behavior moves into space with us.
And I guess looking at the other end, that's the, how do we behave in space? I think, how do we decide? I think it's the importance. I think it's, again, making sure we as the science community educate and place people who are using this space science in all the different possible realms. Again, getting back to how to make sure it's valued.
Yeah, and I think in the absence of a broader conversation, a global conversation, it'll be a market-driven decision-making process, and that one in which that is the largest commercial market is likely to prevail. Yeah. And I don't think any of us want to see that happen.
Next question right here.
So I've worked within NASA for about the last 40 years in climate change, and one of the things that's frustrated me is we have international weather observing systems we all agree to. Europe, US, China, we all have components of it. We commit to do that. There is no designed, committed climate observing system. It's hodgepodge, it's a collage, it's a random collection of whatever we hope stays alive. We put up Terra and Aqua. They were supposed to be every 5-year replaced. We lucked out. They've lasted, 15, 20 years. Yet the world, critically, we're going to be managing climate until humans leave the planet, which is no time soon that we're aware of. So we're not asking the right question. The right question is not what's the best science we can do within our budget, because the U.S. Global Change Research Program has had a flat budget relative to inflation for the last 25 years, despite things like climate change becoming so much more important. And so if you go to the latest decadal survey report that just came out, 2/3 of the climate science objectives, which are all quantified in that report, have critical observations missing in our current observing systems internationally. If we had a climate observing system, we would be filling those holes. We would be doing those jobs. And yet nobody is asking, how do we get to an international climate observing system? How do we reach it? It's Copernicus squared, because there's 10 times the variables of weather. You need 10 times the accuracy to measure over decades you do for weather. And we're not doing it. Now, we've published studies on the economic value of such a system. The number we got is $10 trillion in net present value, and a payback of $50 to 1 if we were to triple our current investment in climate observations and research. And that's everything. Modeling, analysis, like you talked about, we don't have enough people to analyze the data. So there's already half a dozen published papers out there on that. And I've given talks at everywhere, COSPAR, AGU. Nothing is happening. So I wonder what and how, who changes that situation?
Takes leadership.
On that.
It takes leadership. I mean, it really does take leadership, right? How did we get to the moon in 8.5 years? We got there because of leadership. And to me, our aging fleet of satellites that help us understand this planet on the US side is something to really worry about. And then if you're finished worrying about that, then you say, well, how do we go to the next level? And we need investment. We need more investment in technology and sensor technology, in making the satellites cheaper and lighter. It takes leadership.
And I guess maybe it's, again, as we see increasingly the number of people who see the evidence for climate change, whether they're seeing it through satellites or in their backyard, I think that's where we can hope to build the support that will drive to the leadership we need. To me, I think that hearing those numbers, that increasingly people are seeing the signals.
Yeah.
I think we're out of time, actually. So I'm going to stop there and just thank the panel of rock stars in this field. And you're, of course, welcome to ask me questions afterwards. I'll stick around for a few minutes, but just wanted to say thank you all for coming and for your questions, and thank the panel.